Okay, so to start today, I want to present you with a challenge, or more of a question, I guess, than a challenge. But if I were to tell you that I could throw a baseball at a rate of 90 feet per second, would you believe me? I'm not saying would you tell me that you believe me because you want to keep me happy so I don't smash your grade. I'm asking, would you really believe me that I could
Not
throw
really.
per second? And most people would say just that. Well, not really. That seems pretty fast. Just think about it. First base to home plate is 90 feet. That would mean I could throw the ball from first base and get it to home plate in about a second. Well, is that really fast? Well, we're used to seeing speeds in a different unit, miles per hour. And if we look at it that way, if we convert it to miles per hour, we have a better idea as to whether that's really a reasonable speed to throw a ball or not. So let's set this up. First of all, we have to look at 90 feet per second and understand what it means. And when we talked briefly about ratios before, we mentioned this. What that really means is that is 90 feet per 1 second. Because we have to have it in that form in order to be able to do anything with it, including this conversion we're about to do now. So we need to get rid of feet. Feet have to become miles. So let's do that. We'll put feet on bottom. So they're going to cancel out. Miles are going to go on top. 1 mile is 5,280 feet. So the feet have canceled out. Right now we have miles per second. Well, that's not what we want. We want those seconds to become hours. So to get rid of seconds, now since seconds are on bottom, to get rid of it, I'm going to put seconds on top. Now I don't have a direct conversion from seconds to hours, but I do have from seconds to minutes. 1 minute is 60 seconds. So the seconds cancel out. Right now the units we have are miles per minute. That's closer to what we want, but we want miles per hour. So we have to get rid of the minutes. They're on bottom, so we're going to put them on top again. And we do have a conversion from minutes to hours. 1 hour is 60 minutes. So the minutes cancel out. So now we have miles on top. That's the only unit that's not canceled out on top. And hours on bottom. So we are in miles per hour. So let's go ahead and calculate that out. 90 times 60 times 60 is, what is that, 324,000? Over 1 times 5280 times 1 times 1 hour is 5,280 hours. Now we need to divide that out. Obviously, we're not going to leave it like that. That doesn't make much sense. If we divide that out, 324,000 divided by 5,280, we get 61.36 miles per hour. I could probably still throw in the mid 60s. I'd have to warm up for a while. I'm probably going to be able to throw a few balls at that speed before my shoulder would be shot, but I could probably still throw that speed. Well, what this is an example of dual units or rate units, where it's 2 units combined, like feet per second, that we have to convert into a different unit. We do the same process that we have for converting a single unit measurement. We cancel out using that conversion factor. The difference is sometimes here, what we're going to get rid of is going to be on the bottom, so we have to cancel it out by putting something on the top of our conversion factor. And we see that we can have multiple conversion factors, one after the other, in order to make this conversion. Well, we might have a cable that is rated at 0.32 ounces per inch. But we want to know, what is that in pounds per yard? So we will start off with our unit here, the 0.32 ounces. So ounces per inch is 0.32 ounces over 1 inch. We need to convert ounces into pounds. Let's do that first. We'll get rid of the ounces, putting them on bottom, going to pounds, so pounds go on top. Our relationship between pounds and ounces is 1 pound is 16 ounces. So the ounces cancel out. Right now we've got pounds per inch. Well, we want the pounds, but we want it to be pounds per yard. We're going to go back and get rid of those inches here. Inches are on bottom, so we're going to put inches on top. And some of you might know how many inches in a yard. We're going to go through feet. 1 foot is 12 inches. The inches cancel out. And then we have to get rid of the feet. 1 yard is 3 feet. So now the feet will cancel out. And we are in pounds per yard is our unit here. So on top, we have 0.32 times 1 times 12 times 3 is 11.52. The only unit up there is pounds. On bottom, we have 1 times 16 times 1 times 1, so that's 16. And the only unit on bottom is yards. So it's 11.52 pounds per 16 yards. So 11.52 divided by 16 gives us 0.72 pounds per yard for that cable. Other conversions we might run into. We might have something that is rated as 3.4 pounds per square inch, and we want to know what is that in ounces per square inch. Well, we'll still set this up. 3.4 pounds per square inch is 3.4 pounds over 1 square inch. We need to change the pounds, have to become ounces. So we'll do that first. Pounds are on top, so we're going to put them on bottom to cancel them out, going into ounces. The relationship between pounds and ounces is 1 pound is 16 ounces. So the pounds cancel out. Now we look at our square inches. Well, we start with square inches and we end with square inches. We don't have to change those at all, so we can just leave the square inches. So on top we have 3.4 times 16 is 54.4. The only unit there is ounces on top. On bottom we have 1 inch times 1, which is just 1 inch. Oops, so that should have been square inch, I should say. That would be 1 square inch here. Dividing that out, 54.4 divided by 1, that's 54.4 ounces per square inch. So there we didn't have to change the square inches because it was the denominator of both units was square inches. But there will be cases where we do have to change the square inches. We might have 1.2 ounces per square inch, and we want to convert that into pounds per square foot. So our 1.2 ounces per square inch, that's 1.2 ounces over 1 square inch. We have to get rid of ounces and turn them into pounds. So they're on top, we're going to get rid of them by putting them on bottom. Pounds will go on top. The relationship there is 1 pound is 16 ounces. So the ounces cancel out. Right now we have pounds per square inch. We want pounds per square foot. So we need to get rid of the square inches. It's on bottom, so we're going to put them on top to cancel them out, going into square feet. Now here's where you got to be careful. This is not 1 to 12 here. These are not regular feet and regular inches. It's square feet and square inches. 1 square foot is 144 square inches, 12 by 12. The square inches cancel out. On top, we've got 1.2 times 144, which is 172.8. The only unit on top there is pounds. Over 1 times 16 times 1 square foot, that's 16 square feet. We divide that out. I believe we get 9.6, but let's divide it out. Sorry, 10.8 pounds per foot. Sometimes we only have to change the bottom number. We had one where we only had to change the top number up here, where we changed the pounds to ounces and the square inches stayed the same. What if we have something that is listed as 440 ounces per square foot? And I want to know what that is in ounces per square inch. So once again, this is 440 ounces over 1 square foot. That's really the key to this whole problem, is being able to write that rate as being over 1 of that second unit. Ounces are staying the same, so we don't have to get rid of ounces. It's square feet becoming square inches, so I have to get rid of the square feet. Since the square feet are on bottom, I'm going to put them on top to cancel them out. Square inches go on bottom. 1 square foot is 144 square inches. So the square feet cancel out. We have 440 ounces times 1 is 440 ounces. On bottom, 1 times 144 square inches is 144 square inches. We do have to divide the 440 divided by 144, giving us 3.056 ounces per square inch. You might have a car that is currently getting 24 miles per gallon. Now we want to know, what will this be when we convert over to the metric kilometers per liter? Well, again, we're going to set this up as 24 miles over 1 gallon. And the miles do have to change. The miles are going to become kilometers, so we're going to do that change first. Put miles on bottom. They cancel out. Kilometers on top. 1 kilometer is 0.625 miles. The miles have canceled out. They're gone. Now we have to get rid of the gallons as well. Gallons are going to become liters. We're going to put gallons on top here, liters on bottom. 1 gallon is 3.785 liters. The gallons have canceled out. So on top, we have 24 times 1 kilometer times 1. That's 24 kilometers. On bottom, we have 1 times 0.625 times 3.785 liters is 2.366, we're going to call it. 2.366 liters, and now we have to divide that out. 24 divided by 2.366, 10.145, or 10.15, we'll call it, kilometers per liter. Even though a kilometer is much shorter than a mile, a liter is way, way smaller than a gallon, so it's still going to be less kilometers per liter. So, in the metric system, if we need to change, well, actually, one more example I want to do in our standard system before we quit. Let's say you've got a pump that says it is capable of pumping 5,000 gallons per hour. That sounds like a pretty impressive pump, but is it really a good pump? Well, the standard we use to measure pumps is CFM. CFM stands for cubic feet per minute. So we want to convert this to cubic feet per minute. So we're going to put our 5,000 gallons for 1 hour. We have to convert gallons into cubic feet. So we're going to put gallons on bottom, cubic feet on top. If we look up that relationship, 1 cubic foot is about 7.5 gallons. Gallons cancel out. We have to get rid of the hours. So put hours on top. We're going into minutes. 1 hour is 60 minutes. So the hours cancel out. So now we've got cubic feet on top, minutes on bottom. That's what we want, cubic feet per minute. So on top we multiply 5,000 times 1 cubic foot times 1 is 5,000 cubic feet. On bottom, 1 times 7.5 times 60, 450 minutes. We divide that out, 5,000 divided by 450, we get 11.11 cubic feet per minute. A good pump is considered to be between 8 and 12 CFM, or 8 and 12 cubic feet per minute. So 11.11 is actually a pretty good pump. Okay, now we can switch over to the metric system. When we're talking about metric conversions, there are 2 types of conversion we have. There's pure metric conversion, which we'll look at in a little bit, and then there's kind of a mixed metric conversion, where we have metric combined with, generally it's time, because there is no metric equivalent for time. Everything is still on the same standard time scale. So if I have something that is moving at 40 meters per second, and I want to know what is that in kilometers per hour, I have to do 2 separate conversions to make this work, because I have the metric units, which the metric conversion I can do by just moving decimal points, and then I have the standard units, in this case time, in the denominator. So I write this as 40 meters per 1 second. And I'm going to get rid of the seconds, and I'm going to go directly into hours. 60 times 60 is 3,600. So I know 1 hour is 3,600 seconds. The seconds cancel out. I have 40 times 3,600. 144,000 meters over 1 hour. Well, now I've converted the seconds into hours. I've got that part done. I still need to convert the meters into kilometers. Well, because these are metric units, I don't have to do a conversion factor. I can just move the decimal point. On my chart for decimal units, to get from meters to kilometers, I go 3 spots to the left. So my decimal point here is going to have to go 3 spots to the left. That's 144 kilometers. So 144 kilometers per hour. I divide by the 1, which really doesn't change anything. So my speed is 144 kilometers per hour from 40 meters per second. So there we were mixing. We had some standard units with the time in there, but we can have where both units are metric. And we might have something that is 25 milligrams per milliliter. This would be a medication concentration type thing. And we want to know what is that in micrograms. Let's do this. What would that be in kilograms per liter? So 2,500 milligrams over 1 milliliter. Rather than setting up conversion factors here, I'm just going to convert each unit separately using that chart and moving the decimal point. So milligrams need to become kilograms. Milliliters need to become liters. Go from milligrams to kilograms. Go in my chart here. From milligrams to kilograms, I am moving 1, 2, 3, 4, 5, 6 spots to the left. So I have to move my decimal point 6 spots to the left. So I go 1, 2, after that zeros, 3, 4, 5, 6. There's my decimal point. That's 0.000025 kilograms. I have to go milliliters to liters. Well, from milliliters to liters, it would be 3 spots to the left. So I move my decimal point 3 spots to the left there. 1, and then I have to add a 0 for 2 and 3. 0.001. Now, since up here, the denominator was 1, let's get back here. The denominator was 1 hour. I didn't really have to do any dividing out when I got done. I could just turn it into the rate. Here, the denominator is not 1, so I need to divide by that. I divide by 0.001 to make this 1 liter. I divide this by 0.001 to make it 0.025 kilograms. So that gives us a rate of 0.025 kilograms per liter. We might have 1.7 grams per centimeter squared. I want to know what is that going to be in kilograms per meter squared. Well, we have 1.7 grams over 1 centimeter squared. And again, we're just moving decimal points. So we're changing grams to kilograms, centimeters squared to meters squared. So on the chart, get from grams to kilograms is 3 spots to the left. So I take my decimal point and I move 3 spots to the left. I have to add a couple zeros. That's 0.0017. To get from centimeters to meters would be 2 spots to the left. But this is not centimeters and meters, it's centimeters squared and meters squared. And when it's square units, every spot on the chart is 2 decimal places. So the decimal point has to go to 4 spaces. So since there's no decimal point in the 1, we start with it at the end of the number, and we move it to the left 4 spots. We go 1, and then we have to add zeros. 2, 3, 4. That's 0.0001. And again, we have to divide that out. We divide by the bottom number, 0.0001. So on bottom, 0.0001 meters squared divided by 0.0001 is 1 meter squared. 0.0017 kilograms divided by 0.0001 is 17 kilograms. So that gives us 17 kilograms per meter squared. Okay, so with that, just to give you an idea, we are closing in on the end of Unit 3 here already. Next Monday, we'll do a quiz and do some more of these compound units. I actually have a meeting I have to go to today, so we're cutting it a little short today. We'll do a quiz, and they'll probably be looking at putting the test again next week, Thursday. So Unit 3 test next week, Thursday. What is that? March 4th, I believe. So be ready for that coming up. For now, your homework. Still out of that packet we've been working in. Page 238, problems 57 through 64. And page 266, problems 55 through 62. I'll be on the network for a little while here before I have to duck out. If you want to get started, I'll be here to answer any questions. Otherwise, that is all of our new material.